Hey guys, Mike here, bringing you my 5th tutorial on Kerbal Space Program. In this tutorial I'm going to be showing you how to build a space plane in Kerbal Space Program. I'm very sorry that this tutorial is a bit overdue. I have had some problems with memory, and then we had Christmas and New Year's, and then I've recently actually just deleted Kerbal Space Program and started afresh, got rid of all my mods and everything like that, just got rid of all the junk that was on it. So I started again, but I'm not too fussed. I kind of wanted a fresh start, and so yeah, here we are. So what we're going to do is we're going to go into a sandbox mode, just so then I've got access to all the parts, and we're going to want to go into the spaceplane hangar for obvious reasons. Now, in my last tutorial, if you saw it, we made a plane, a normal plane, into Kerbal Space Program and flew it to the airfield just across the pond, next to the Kerbal Space Center. So this time, what we need to do is we need to make a plane which is going to be fast enough to get into orbit. Now, one of the main things that the whole thing about a space plane is that it's usually classified as an SSTO, and that stands for single stage to orbit. So normally you'd have rockets, you'd press the space bar and you'd have multiple stages and debris going everywhere, and it's a bit mucky and not very pleasant. Whereas with a single stage to orbit, you don't need any of that. You just have your plane, you take it off, get into orbit, maybe refuel it in orbit, fly it to somewhere, say Lathe, one of Jules' moons, and then fly it back and then land at the Kerbal Space Center. No debris, no mess. It's perfect. So what we need to do with that is, thankfully, due to the KSP update 0.23, we have a new engine at our disposal called the Rapier engine. Now this stands for Reactive Alternate Propellant Intelligent Engine for Rockets. And what this means basically is that it's the only engine in the vanilla game that can switch between air breathing and rocket fuel, because obviously when we get into the vacuum of space, there isn't any oxygen, so we can't use air breathing engines, and air breathing engines are much more efficient than rocket engines, so we want to try and use them as much as possible, whereas this is the only engine that can switch between the two. There are many mods that you can download which add them, but I like to try and keep the game vanilla if possible. That's why I cleaned out this game, because I just wanted to start again. So yes, thankfully this is kind of cheating, because previously you had to add maybe 2 LV909s and then a turbojet engine, and you had to carry up some dead weight and you had to compensate for either, so it didn't make it that easy. So generally, this is quite an easy time in Kerbal Space Program to make an SSTO, but still not easy as it sounds. So I'll talk you through it. So first of all, we're going to want a Mark 1 cockpit, and we're just going to add some advanced SAS onto the back of that. Now, one problem that you always have with these Rapier engines is the fact that they don't generate any electricity. So for the time being, if I go into utility, we're going to go with the Z1K rechargeable battery bank. Oops. And, oh god, where's it gone? And lose it in the advanced SAS. Oh, wait, hang on, bear with me. Right. Quantum core. Oh yeah, I have got a few mods on this, which is just Quantum Struts and Kerbal Engineer, and I'll show you Kerbal Engineer in a second, because I really recommend that as a mod. Where is it? There you go, the Z1K rechargeable battery bank. So we put that on the back. So we're going to add a few ways of generating electricity, but this is just going to be a little battery pack for our space plane, because the last thing we want is running out of electricity halfway through a flight, which could potentially just ruin the whole flight. Now, another thing with these Rapier engines is they're quite heavy and they don't generally have that much thrust, especially at low altitudes. The thrust is only about 90 kilonewtons. It's only until they gain altitude that they actually reach their full 175 kilonewtons. So what we're going to do, we're going to have 2 of them, and I'm going to use a design that I haven't really tried before with the space plane, and that is using 2 side by side, whereas normally you'd have 1 down the centre and then 2 on the left and right, which balances it out more evenly. Whereas I'm going to try just 2 fuel tanks right down the centre, each with a Rapier engine on the back. So for that, we're going to need a splitter, and if we go into structural, go onto the, oh no, it's on this page here, the TVR 200 stack bicoupler, and we're just going to add that onto the back of the rechargeable battery bank, and this gives us 2 slots in which we can now put a some fuel caches. So I'm going to add, first of all, some jet fuel, just some easy storage of liquid propellant, which is liquid fuel, which is what we need, only what we need for when we're in the atmosphere, because we have intake air. And then I'm just going to add some rocket fuel, which there we are, which is the FLT800 fuel tanks, which is, I believe I used them in my last video. So after we've done that, we're now going to have the Rapier engines on the back, to have 2 of them, placed on the back like so. So this is going to be the basic body of our space plane. So now we're going to need to secure these 2 rockets, well, these 2 fuel tanks together, because even though they're on the same slot here, the back of these isn't connected. As you can see, there is a space between them, so as soon as we're under throttle, it might start getting a bit hectic if they're not secured properly. So we're going to add some struts, which are these EAS4 strut connectors. Make sure you've got 2 of them, and we're just going to position them evenly throughout the rocket, just to ensure that we won't have any mishaps during the flight. Just going to put 2 on the top and 2 at the bottom, the front and the back. Like so. Okay, so now as with the plane, like we did in our previous video, we need to add some vertical stabilizers, because otherwise we're not going to have a very stable flight. I'm going to use the Delta Deluxe winglets in order to do so. I'm going to swap it over to the normal angle snap, just so then we get symmetry on both sides, and we're going to have 2 just because we might as well, considering actually I might go with a different design. No, we'll see how it goes. So yes, we're going to have these 2 vertical stabilizers like so. You don't normally need to, because it creates additional drag, but in terms of this rocket with no central alignment, we are going to have 2. So now we need to add the wings, and the wings, usually I tend to use these swept wings right here, because they're very, very easy to use, and we're going to use those in our build today as well. So we're going to change them to the normal angle. No, actually, we'll keep them on the square angle snap. So we're going to place them so that they are in the centre of the middle rocket, or making sure that we have centre of mass, centre of lift, and the centre of thrust out. Because if you remember in our last video, we need to make sure that our centre of lift is directly behind our centre of mass, and our centre of thrust is directly behind both of them, which it is at the minute, and it's going to stay that way. So I'm going to add these wings in here. And one thing we are going to do is hold the shift key and press S to straighten out these wings, because we're going to be adding more swept wings on this side of these, which are going to curve around, because these wings on their own won't provide enough lift in order to give us a stable flight that we desire. So I'm going to alt click these to copy them, and we're just going to have 3 of these like so. Okay, so now we're going to add some swept wings onto the end. One. It starts getting a bit tricky. If you change it to the circular angle snap, that can sometimes make it a bit easier. I'm saying that, there we are. Right, that's 2. And then that's fine. Okay, so now we have 2 sets of swept wings either side. They're not perfectly aligned, but that's not a problem, because these swept wings are actually very stable. So as long as we've got a flat edge at the front, which we do, that's not going to be a problem. So now that you can see we have our swept wings out, we're going to need to secure these swept wings, because at the moment these are 6. Wait, no, hang on, let me do the maths. 3, 6, 9, 12. 12 different sets of wings here, because these, even though they overlap each other, they're not connected. They are still individual wings, so they'll flap about like crazy. So we need to secure these. So we're going to use these EAS4 strut connectors, making sure our angle snap is on the circular mode. And we're going to place these on the top of the wings, and then connect it to the next one, to the one that's next to it, like so. So as you can see, that wing is now connected to that one, and it becomes a single wing. So we're going to do that with all the wings to make them into 2 big wings. Making sure that's on properly. Yes, that's on. So there we are. So now we have 2 big wings instead of 12 separate ones. And then now we're going to add supports onto the bottom just to just try to minimize bending of the wings when we are experiencing lift, because if these wings start bending, everything goes tits up. And it really does affect the aerodynamics of this space plane, which is not what we want, especially when we're returning to orbit, because then it can cause some serious problems. So now that these are in place, we are going to just do a few other things. I'm actually going to move these wings forward because I'm going to add some advanced canards onto the front here, or actually some winglets, just so then we have a bit more lift at the front. At the minute it's quite at the back, so when we try to take off it'll be quite difficult and we won't have much control. So if I just turn these on, put angle snap here. Oh, that's alright actually. That makes... see how that goes. It's not too bad. Okay, so now we need to have some small control surfaces. We're going to have 2 here, and then we're going to have a further 2 on the ends here, so then we can turn easily. Remember, we're going to use these smaller ones because they have a better lift to mass ratio than the larger ones. Okay, so now that our centre of lift is behind the centre of mass, and our centre of thrust is directly behind those two, which it is, we now have a space plane which can fly, and we now just need to add some of the finishing touches. So we're going to add some wheels. We're going to have them here actually. You're going to hold shift and press, oops, there we are, going to press Q until we make those central, and then I'm just going to put a wheel on the front as well. So, and then we need to put some electric generators on. So going to utility, we're going to find the NB and UK radioisotope thermoelectric generators. Make sure they're on 2, and then we're just going to line these up against the front of the... actually, tell you what, I'm going to put them at the back just to add some more weight on to bring the centre of mass backwards. So, which should provide enough electricity for our small control surfaces to work effectively. And then we are also missing one of the main points about a spaceplane, and those are air intakes. Now, one major thing about air intakes is the fact that for an SSTO to be successful, it has to be able to get up to high altitudes, because the higher the altitude, the faster it can go on air breathing engines, so the less rocket fuel it has to use. So, in order to do that, we need as many air intakes as possible, so we can get as high as possible. Because the more air intakes you have, the more air we can get in, because the higher up we go, the thinner the atmosphere is, so the less air intake we get. So we need the many air intakes as possible to get as much intake air as possible. And also, we also want to try and get as fast as we can, because the faster you go, the more air that's forced into the air intakes, so the more intake air you have available to thrust the engines further, so the faster you can go. So it's like a vicious cycle. So I'm going to show you a neat trick that you can use to basically double the amount of air intakes you can have on a particular SSTO. So we're going to go and find where is it? There you are, this cubic octagonal strut here. And we're just going to place it on the end of a wing, making sure that we have symmetry in place. And I'm just going to press Control Shift just to make sure it's straight, because at the minute it's slightly... there we are, yes, you only need to do it once to make sure it's straight, because if you start having the air intakes on the wrong way round, it can affect the aerodynamics of the SSTO. So now that we have these here, we're going to go into aerodynamic, and we're going to find the RAM air intakes, because they are the best air intakes in my opinion. And if you can see, the cubic octagonal strut does have 2 places where you can place things, and therefore, if we take it, I'll take it off 1. These can be a bit finicky. Just put that to one side. Try these again. I'm just going to put it on single symmetry and no angle snap. And make sure it's aligned. Ah, there we go. Right. So now, yeah, you need it on single symmetry and no angle snap. And now we are able, or was able, put one, there we are, on the back. So now we've got a ram intake on the back, and then we can put one on the front as well. So effectively now we have double the air intakes on the same place. So you can basically effectively double the amount of air intakes you have on any SSTO. So I'm just going to click on the little girder segment, press X to double them up, and just find a good place for it. There's a good place. It'll do nicely. So now what we need to make sure we find is, if you can't see the modular, because you have to click on the click on the modular girder segment, just zoom in like this and then click on it inside the wing. Make sure you alt click to copy, because if you click on the wing it can get a bit messy, and then just keep rinsing and repeating that. We want to keep making as many of these little air generating machines. We want as many of these as possible. Try and space them out evenly, and look, see if you can get a little segment there, you're laughing then basically. And you can keep them the same on the first section of the wing, and then once you get onto the curved segment, you'll have to readjust again because they'll be off to one side. So if you hold shift and press S twice, you'll get them straight again. And remember to alt click makes them straight. We're going to keep putting these on the wings. See if I can fit one on the end. Yeah, I can fit one on the end. There we are. So now effectively we have 1, 2, 3, 4, 5, 6, 7, 8. So 16 on this side. So 32 air intakes in total, which is 16 for each engine, which is absolutely ridiculous. But that means that we'll be able to get a really high altitude, around say 35,000 meters. So we'll be able to accelerate to, I think, a roughly 1,800 meters per second just using air breathing engines, which is really good because that means we'll be able to get into orbit and have loads of fuel for interplanetary transfers. So I'm just making sure I haven't missed off anything. Wheels, air intakes, wings, engines, electricity. I think I'm good to go. Oh yeah, I'm just going to show you one actually mod that I got just before then. It's called Kerbal Engineer. You have to add on this little sort of motherboard section, and then it comes up here and it actually tells you your total weight ratio, mass, and what kind of stuff. So at the minute the whole spaceplane just weighs a little under 20 tons, but it's got a thrust of 380 kilonewtons, so its total weight ratio is 1.98, which is pretty fantastic. So whereas atmospheric, you can go for just in the have the main display of how it will perform in a vacuum, and then you can have it in the atmosphere as well, which is exactly the same, which is very, very helpful. So yeah, when you're building a spacecraft, it's always good to reference this, just to make sure you have a total weight ratio of over 1, because otherwise it's not going to work. Around 2 is exactly where you want it to be, which is perfect. 1.98 is brilliant. So, get rid of that. And I think we're good to go. So I'm just going to name and save this. YouTube, oops, SSTO. Actually no, I'm just going to call it SSTO Mark 1, because if this is successful, I might use this design quite a lot. So I'm going to click launch. And plop down on the runway. Oh no, I just realised I've forgotten something. Never mind, forget that. One of the main points you have to remember about using a spaceplane is the fact that you need to set up some action groups. Now, action groups enable you to do various things on the craft during flight that you can just use during. So it's basically like assigning hotkeys. So what we are going to use is we're going to assign a hotkey to change the engine from closed cycle to air breathing, and we're going to have another one to turn off the air intakes as well. So for number 1, I'm going to use to take off the air intakes, and because these are doubled, I only have to do it on one side. So we're going to click custom 1, and we're just going to choose these options here, which is toggle intake. We don't need to do it on both sides because we did use symmetry. So whatever I do to the left hand side, it will take effect on the right as well. Now this is a great advantage because it means you don't have to if I start turning off air intakes manually on the left hand side, that will start affecting the aerodynamics of the spaceplane, and it will take me ages to do this manually while I'm flying. So the aircraft will start spinning, I won't be able to control it, it's going to be a nightmare. So if you can do all of them at once, it's really handy, as well as the rockets as well, because when if they start to flame out, you can toggle them, and if one of them flames out and the other one doesn't, you'll start spinning and it all just becomes a huge mess. So for the first hotkey, for number 1 hotkey, we've been able to assign all these ram air intakes to toggle, and then for number 2, we're going to choose to switch the engine mode of the Rapier engine, and because I've done symmetry, it applies to both of them, so that's not a problem. So there we are. I'm going to click save and launch. Okay, so now that the SSTO is on the runway, we've just got a few things to do before we take off. By the way, this flight might not go perfectly, but I'm expecting it will, but there's always a chance that it might fail, so we'll just see how this goes. So I'm going to press T to turn on SAS, press the spacebar to turn on the rockets, just checking that they're in air breathing mode, which they are. Check that the air intakes are on, all systems are go, hold left shift to throttle up. Now the standard plane controls are W, A, and D. I've configured them to use on the right keypad. Actually no, I haven't. Oh yeah, because they've gone, haven't they? Never mind. So the W, A, and D, and then Q and E to yaw and roll. So now that we see with these Rapier engines don't have much thrust low in the atmosphere, so we're only hitting about 100 meters per second with both of them. We're going to try pulling up. Might have to go to the end of the runway. We are doing, which is absolutely fine. I'm going to press the G key to retract the wheels, and then once you've taken off, you want to pull up to around about 45 degrees, and you want to maintain that angle, because we want to try and get to a high altitude as quickly as possible, and because we don't have that much thrust, we can't exactly go vertically up, because that's probably not very efficient. So 45 degrees is a good mix between speed and gaining altitude. Take a quick thumbnail here. So this part of the journey can be quite boring. Basically what we are planning to do is get to around about 35,000 meters. That's our target altitude. We also, when we start nearing 20,000 meters, we need to keep an eye on our intake air, because with 2 engines we want to make sure we keep it above 0.2, because if it goes any lower than that, we probably have a risk of burning out, which is disastrous. But at this stage we've still got 6.4 intake air, which is just crazy. It's more than you'll ever need, but just, you know, as a beginner, as a beginning tutorial, it gives you a lot of leeway. One thing to note about the Rapier engines is that the higher you go in the atmosphere, the more your thrust increases, because at the minute on the ground it was 95, I think, the kilonewtons, the thrust, and now it's 99, and you'll see that the higher we go, it'll just keep increasing in thrust, therefore we're able to increase speed. So now we've actually hit 140 meters per second, whereas before we were at about 70. Which is quite strange actually for a plane, because the higher you go, the faster, the more you gain altitude, the higher you go. It's just, I know that's the same with say like normal planes, because the atmosphere is thinner, so you have less drag, so therefore you're able to go faster, which does make sense. But I don't understand why the thrust increases. I'll have to look that up. But also, as you can see, the liquid fuel as well. We are virtually sipping fuel. If we used rocket fuel up to this point, we'd have run out of fuel by now. Whereas we've still got all of our oxidizer left, which we are able to use while we're in space, and we have only taken a very small amount of liquid fuel, which hopefully will be coming out of these engines, which they are, which is why I put them there. These two are basically to contain fuel for the atmospheric section, and these for the in space. So now we've hit about 12.5. You'll see that our intake air starts to decrease because we're now leaving the thickest part of the atmosphere and entering the stratosphere. I think this is now. Please don't correct me on that because it's probably wrong. Oh, actually, I quite like that thumbnail. I'm going to be taking a few of these. So. Please don't get annoyed if I keep taking thumbnails. I must find a perfect one. As you can see now, we've hit 16,000 meters. We're now at 320 meters per second. The thrust of our rockets is 120 kilonewtons. Everything's increasing as we are increasing altitude. So we want to probably start leveling ourselves off now, because as you can see, our intake air has started dropping to 1.4. So we need to now start increasing speed more than altitude, because the faster we go, the more intake air we have. So the higher we can go, so therefore the faster we can go. So it's a good. You will need to get a good balance of altitude and speed, because you can't go fast without being high, but you can't go higher without being fast. So it's a good balancing act. It gets easier the more you practice. So I'm now going to start going more forwards as we try to increase speed, because we're now at 700 meters per second and increasing very quickly. Our thrust is at 175 kilonewtons now, which is very nearly the maximum that these engines can go. I also want to make sure that I don't pitch down enough that we start decreasing altitude, because we want to keep increasing altitude, because obviously the higher we go, the faster we can go. So we're nearly going to break 1,000 meters per second. If you start seeing re-entry effects, which we might do, that means you're usually too low, that you're going too fast, too low. So you want to make sure you're about over 20,000 meters before you really start increasing speed. And so we're making sure that we keep. There we are. Now that we're getting a bit higher, the thrust now starts decreasing on the rockets, but it doesn't really make much of a difference because the atmosphere is becoming so thin that the air resistance is virtually nil. So even though the thrust is decreasing, we're still increasing speed quite rapidly. It's going to pitch even more further down, just then we gain speed even quicker. Now we've got to keep an eye on our intake air now. Intake air is at 0.3, so I'm going to pitch down even further and decrease the throttle ever so slightly, because we don't want to go underneath 0.2, so I'm going to decrease it even more. If it goes over 0.2, you can't be at full throttle. So 0.2, 0.19, so we now need to make sure that we are flattening out our descent, because we want to make sure that we don't have a flame out. If we do, I'm going to have to switch. Keep decreasing the throttle now, so then we can't, to try and prevent a burnout. Trying to keep an eye on my spaceplane to make sure it doesn't spin out. We are slowly increasing speed still, so I'm happy to keep firing the air-breathing engines. 1700 meters. What I'd like to get to is 1800 meters per second. I've pretty much reached 35,000 meters now. Wow, look how fast we're going. The island that we're on is not just gone within a matter of seconds. So as soon as we've hit 1800 meters per second, I'm going to switch to my rocket engines and then blast up at 45 degrees to get ourselves into an orbit. And I actually see that we've started decreasing altitude, which is not what we want, so we want to try and pitch up quite sharply. You need to make sure that you're quite proactive about getting out of a descent. So now we're over 1800 meters, we're at 35,000 meters. I'm going to press 2 to switch to rocket engines, full throttle, and pitch 45 degrees upwards. Now we want to look at our map and watch our apoapsis increase very quickly, because our speed is now going to start going mad, and we want to conserve as much fuel as possible. So I'm going to aim for about 100,000 meters, because we're still in the atmosphere, so the apoapsis will probably drop by quite a significant amount, even though, right, so 100,000, so it's still probably drop, because as you can see it's still decreasing to about, I reckon about 80,000 meters to about 75,000, which is an ideal orbit. Because we want to try and use as little rocket fuel as possible, because it does burn through it like crazy with 2 engines, and we don't have much, so we need to conserve it as best possible. Actually, it's going to be higher than I thought. So now, just like we would a rocket, we just basically need to wait until we hit our apoapsis. It shouldn't be too long, so I'm just going to use the arrow keys to just time warp forwards, so we reach it a bit quicker. as you can see, we're actually sort of quite a wide orbit to begin with, and that's because we're already going at pretty much orbital velocity before we've even got into the orbit. And that's one of the things about knowing if you've got a good space plane. If you've pretty much already hit orbital velocity before you've even entered into an orbit, that's a sign of a good space plane. So I think I might use this design quite a lot, because it's the twin-engined design without a single fuel cell down the center. It's actually pretty good. So it's stopped at 89,000 meters, which is really safe orbit. So we need to remember what I showed you in the. That's quite a nice thumbnail. We need to remember what I showed you when we were getting a rocket into orbit. That when we start getting close to our apoapsis, we need to go down to the prograde marker on the nav ball, which I'm going to slow down time now to. I'm just going to angle myself using WAS and D. This advanced SAS is really helping now, as well as the control surfaces. So when we get to our apoapsis, we want to make sure we keep it as close to us as possible. We're going to get into an orbit pretty quickly, so kind of got to be pretty proactive about this. So when we get closer, I'm going to increase the throttle using the left shift key, very gently, and I'm going to angle down a bit just to bring the apoapsis marker closer to me. So we want to try and keep it as close to us as possible in order to gain a synchronized orbit as possibly. And we need to keep an eye on the markers. As soon as they swap sides, that is when they are equal, and we want to have a circular orbit as possible. There we are. So as soon as they switch, press X, and there we are. So we're now at 89,000 meters and 92, which is a really circular orbit. And look how much fuel we've got left. Nearly half a tank, which is absolutely amazing. So I would say this has been a very, very successful space plane. I'm just going to quickly take a snapshot. There we are. I always take loads of screenshots. But there we are, guys. That's how you get how you build a space plane and get it into orbit. In my next video, I'm going to make this into a 2-part tutorial, and then in the next tutorial, I'm going to show you how to get this back and land it at the Kerbal Space Center. Thanks for watching, guys. If you enjoyed the video, please comment, like, and subscribe for more Kerbal Space Program videos. Cheers.